All right, that looks like a healthy amount of people that we've got in the audience now. I think it's time to get started. Thank you all for joining us today. My name is Philipp Schmid. I'm going to be your host for today's webinar. With me on the call, we have Michael Schmid, Head of Technology at Amazee.io, to lead us through the webinar today titled Lagoon 2.0, Deploy into Kubernetes and more. Throughout the webinar, we'll have several sectional Q&A sessions that allow us to ask questions throughout the webinar instead of just at the very end. You can ask questions by using the Q&A function that you find at the bottom center of your Zoom panel. That is different from the chat, makes it a lot easier for us to answer those questions live in every presentation, and we'll make sure that we address everything accordingly. We'll also dedicate some extra time to all open questions at the very end in a summarizing Q&A session, just in case something wasn't actually addressed in one of those sectional Q&As before. Alrighty, let's get deeper into that. Without any further ado, I am opening up the floor for today's speaker. Over to you, Michael.
Thank you. Hello, everybody, and welcome to our webinar. We're super excited about this one. We want to give you a sneak peek into Lagoon and show you what it is going to be able to do. But first of all, there might be some people here that have not heard about Amazee.io. A short, quick intro. So Amazee.io is a fully managed cloud and dedicated container hosting company. And as you might have guessed, we're using Lagoon for that. Lagoon can host anywhere in the world. Because we're using containers, we can pretty much wherever there's a data center, wherever there's a server, we can host on there. We pride ourselves in providing support via chat. So if you're a customer of us, you directly talk to us via chat systems. You can talk to me, you can talk to all my system engineers, and that will help you right away. And then everything we do is open source. Everything that you will see today is also open source. Keep that in mind. That means you can see exactly what code is running, which versions, which configurations, which script we're using to provide the service that you're using. And we have global clients, including government, financial services, universities, media, agency, or also startups. So we are having a broad, different type of companies that all need really good hosting that has good uptime, high performance, and is secure. So the agenda for our webinar today is first, we're going to have a quick Lagoon overview. What is Lagoon? What is it doing? Then we're going to see a bit into the history from Lagoon 1.0 to 2.0 and see what actually is in 2.0. Then we're going to see a live demo of deploying into Kubernetes. And we're going to have a bigger sneak peek into the future, what is going to come with Lagoon. But first of all, what is Lagoon? So Lagoon, in one sentence, basically builds and deploys your Docker-based applications. That's what it tries to do. With that, first of all, in order to do Docker-based deployments, you need Docker images. And so Lagoon and the Lagoon maintainer team create base images for many different services and applications. So we'll see a list of them later, but basically whatever you want to run in web applications, you can run with Lagoon, and we have base images for PHP, MySQL, all these kind of things. So this means it is much easier for anybody to start using Docker and containers to deploy their web-based applications. Lagoon is able to talk to Kubernetes APIs and knows how to create different Kubernetes objects. So it knows, for example, that a Drupal needs a database. It knows that it needs a file system. It knows that it needs persistent storage. It knows that it needs different types of services, and all these different kinds of Kubernetes objects that are needed, it can create for you. So you don't need to learn how exactly do I deploy a Drupal or a WordPress or a Symfony or any other application that you want to deploy into Kubernetes. Lagoon has all of that knowledge already and does it for you. So Lagoon knows which objects are needed, which are not needed, how to migrate them, and all that type of stuff. Lagoon does it all for you. Plus, Lagoon also creates different namespaces for each branch. We're going to see that in the demo later, but also we have support for pull requests. So Lagoon creates individual namespaces for that in order to separate the different environments from each other in namespaces. This makes it much more secure and much more manageable. And Lagoon runs pre and post deployment scripts. Some applications like Drupal, they need to run specific commands after deployments or before deployments. For example, you want to import the configuration via Drush, and Lagoon has support for that. So you can tell Lagoon which commands should run in which cases, and Lagoon will run them automatically for you. And everything that Lagoon does is fully automated, but it's also scriptable. Everything is API first. So for example, if you want to inject or add a specific step, you can do this. You can see which deployment has already run, which environment exists, where are they deployed, what's the status. All of this is scriptable via the GraphQL API that Lagoon provides. So how does a stack of Lagoon actually look like? At the very bottom, the white part, we have the infrastructure, which can be provided, as mentioned, that can be provided anywhere in the world. Of course, the three big ones, Amazon AWS, Microsoft Azure, or Google Cloud, are the predominant ones, but at the end, this can be hosted anywhere in the world that you have some servers. You can even do bare metal if necessary. Of course, a lot of things today are virtualized, but it would also be possible to do bare metal. On top of that, we then have the infrastructure configuration and the operating system. Today, this is mostly Linux, even though Kubernetes now more and more can also do Windows-based operations. And then on top of that is where Kubernetes sits. So Kubernetes basically is the container orchestrator that manages the containers, deploys them to the correct nodes, and restarts them if they died, and all that stuff is done by Kubernetes. And that's where Lagoon comes in. So Lagoon sits between your application that is provided by our customer, the engineers, and of course the data as well that is connected to that, and Kubernetes. So Lagoon sits in between and basically knows how to deploy an application, how to manage these applications inside Kubernetes. If you are a customer of Amaze.io, all of this will be managed by us as Amaze.io. So that's the part that we are providing. We're using Lagoon and Kubernetes and Linux to offer the services. Like mentioned before, Lagoon has a lot of different support for almost any open source framework you can find out there. We come from a Drupal world, so we have a lot of support for PHP. And of course, we can run also other PHP-based frameworks. That's WordPress, Joomla, Laravel, Magento, you name it. But we also have customers that use it for Python-based, Ruby-based, and of course, the big topic right now, Node.js. You can run either Node.js-based CMSs or decoupled environments like Gatsby, React, Vue, Angular, whatever you want. And then, of course, we also have support for many of additional services that are needed to run these applications. So databases, we have MariaDB, Postgres. We can have Solr, Elasticsearch, MongoDB, Varnish for better caching, Redis, key value storage, RabbitMQ for messaging queues. All of it is possible to host inside Lagoon. We always joke, if you can run it in a container, Lagoon will deploy it for you. So that's the requirement, and that's what Lagoon does. So let's look a bit into the history, what has happened in the last couple of months on Lagoon from version 1 to 2. Version 1 was released end of last year in August 2019, where we released Lagoon version 1 with full role-based access control and group management. This was a huge step for us because we finally had the capabilities to create different groups, assign users to groups with specific roles, so that we could really narrow down what an individual user can do in a Lagoon environment. That means, for example, you can restrict that the developer cannot access the production environment, or cannot see the backups, or cannot push into an environment, or cannot deploy an environment. All different types of things we're able to do. And because this was quite a big change, this was the first major release that we had with Lagoon version 1. Then in October, we relaunched 1.1 and we switched to open distro for logging security. This allowed all our customers to directly have access to Kibana, to see the logs in their own Kibana dashboard, where they can see the logs, they can create dashboards, visualizations, but only narrow down to exactly the logs of the projects they actually had access to. Lagoon 1.2 came in December last year, and we integrated Harbor. Harbor is a Docker registry and also a Docker security scanning tool, which automatically scans all Docker images that are running inside the cluster. And it alerts you if it finds Docker images that have packages installed that are not secure anymore. And you can imagine with having with thousands of containers running, security is a very important part. And so Harbor brings that to us. Also, we launched PHP 7.4, which just came out a couple of days before that. We launched the support as well, because we really want to provide our customers to use the newest features of PHP and of course also other systems or programming languages out there. So that's why we launched that as well. Then 8th of February 2020, this was an interesting one. There was actually the first security release of Lagoon, was version 1.2.1, where we within 22 hours figured out that there was a security release, and we launched or we released a new version of Lagoon, which was really exciting to see how the security process that we had already in place, we actually had to do them. And it was nice to see that we were able within 22 hours to release completely new version of Lagoon, fully tested across all clusters that we were running, and we had them secure. And then just a couple of days ago, we released Lagoon version 1.3, which brought the first self-service tool inside the Lagoon UI, which allows you to manage the SSH keys by yourself, finally. And we also deprecated the PHP versions that are really old now, and also Node.js versions. So this means we do not suggest to use these versions anymore. They're still there if you really need them, but we really suggest you to update to new versions. So you can see there is almost a release now once a month, and we try to keep that up. We really push hard, we push ourselves to have better processes, better release cycles, and gonna release more versions in the future. Now we're on the path to Lagoon 2.0. Before we release Lagoon 2.0, we're actually gonna release 2 more versions. The first one is gonna come beginning of April this year, so just in a couple of days. And this is gonna be the first version that will actually bring the first Kubernetes support. It's not gonna be full Kubernetes support yet, but this will be the first capability to actually deploy into Kubernetes with Lagoon version already 1.4. And we do this because we already have the first customers that we deploy against Kubernetes, and we need to learn a bit more how all of it works, how best practices, things like that, so we can then bake them into Lagoon 2.0, the big release with Kubernetes. And there's going to be a version 1.5, probably early May right now planned, and it's going to bring another highly requested feature, which is blue-green deployments, and which will allow much better production deployments with actually blue-green systems. We're going to have a specific blog post about that, how this all works, but this is really exciting because it will allow zero downtime, production deployments, and many other things. Plus, we're also improving our logging infrastructure. We want to make logging infrastructure even better, faster, that you can filter even more, and we'll see a bit more things that we're going to plan in the logging even more. So there is a lot going to come. Before we jump into Lagoon 2.0, we want to shortly look into what are actually the benefits of Kubernetes. Why all of this? Why not just stay at OpenShift, the system that we currently support with Lagoon? So first of all, we chose OpenShift a couple of years ago because it brought all the security and multi-tenant features that we needed. For example, Kubernetes at that time did not have the role-based access control. It did not have capabilities for software-defined networking that allows you to separate specific namespaces from each other. And there were no network policies. All of that was able to be used by OpenShift. But the Kubernetes community in the last couple of years stepped up and implemented all of these things that we felt are needed to really use Kubernetes in an enterprise environment. So Kubernetes has all of that now, so now is the time to support Kubernetes out of the box. It's also, Kubernetes is more cost effective compared to OpenShift. OpenShift is if you want the enterprise version of Red Hat, you're going to pay licenses for that, and that can be quite expensive quite fast. So we have many customers that cannot afford that, and so especially if you wanted to have your own dedicated cluster. So we try to find more cost-effective ways, and this is why we want to use Kubernetes. Also, in the meantime, there are now many enterprise managed Kubernetes services out there. You've probably heard of them. They're called EKS from AWS, AKS from Azure, or GKE from Google. These are managed Kubernetes services where you don't need to run your own control plane. You just start your control node, your compute nodes, you add them to already existing control plane, and that's it. That makes it much easier than if you want to run your own Kubernetes cluster that you have to manage and upgrade the control plane and all that stuff. And of course, there are many other managed Kubernetes services out there. The DigitalOcean has some, IBM Cloud offers some. So there is a lot of different ones out there. We really see that this is the way to go. And right now in Lagoon 1, you cannot use them. And with Lagoon 2.0, you're really able to be using them. And another problem is that we have many customers that really want to be on the edge of the possibility, and we couldn't offer them. One of the questions that we get many times is cluster autoscaling or using the spot instances. That's not really possible for us to be used right now. With managed Kubernetes services, still will be really cool. We're already using it, and it's really cool to see it. And also new technologies like TLS 1.3 or maybe even HTTP 3 that is out there already. Some browsers support this, and we have customers that want to use this, and that's unfortunately not possible with OpenShift. And then the last and really important part that is important to us is we really believe that Kubernetes as a fully open source tool or project, we really believe that this fits much better to our understanding of how things should be done with Lagoon. So we're really happy. And to then everything that you will have is all completely open source. So let's look at it. What is going to be in 2.0? Right now, we expect it to be released in June, July 2020. You can imagine with everything that happens right now in the world, planning is a bit hard, but we really think that June or July it's going to be. First of all, no surprise there, I guess, full Kubernetes support. This means we're going to support everything that is currently able to be done with OpenShift, and Lagoon is going to be done with Kubernetes as well. Another very important thing, no breaking changes in Lagoon YAML and Docker Compose YAML. So this means if you have currently a project that is Lagoonized and is able to deploy with Lagoon 1, you don't need to change anything in your Git repository and in your code in order to deploy with Lagoon 2.0. There will, though, be some breaking changes in the API, hence version 2.0. Mostly, the most important thing is the OpenShift object will be replaced by a Kubernetes object. Now, not many people are using the OpenShift object directly via the API. They maybe trigger some deployments, they maybe work with the environment, and you don't really need the OpenShift object at all there. So this is only going to affect a super tiny small piece of our customers that maybe need to change a bit their code that they use to interact with the API. The really interesting thing is, though, that Lagoon by default will assume that if you added a Kubernetes cluster, that this is actually Kubernetes. It will still, Lagoon 2.0 will still be able to deploy against OpenShift. We're not going to remove that. But by default, Lagoon will assume that whatever cluster you gave it is a Kubernetes cluster. And then if it's an OpenShift, you then actually need to configure some special things. There will be documentations, of course, that does all of this. But that's really, for us, we believe Kubernetes is going to be the future, and that's why we make it the default. Some other features that we're working on is we are planning to have capability to deploy into multiple Kubernetes clusters per environment type. So this means you could have a Kubernetes cluster for all your production environments, and you can have another one for your development environments. And Lagoon will automatically see that if you deploy a production environment, it will go to Kubernetes cluster A, and then if it's not, it will go to B. So this will be automatically handled by Lagoon. We really see that this is the way how to run stuff in the future with multiple smaller Kubernetes clusters than these huge clusters that more was the OpenShift way to do it. Plus, because we will have a lot of migrations coming up at Amazing.io, we want to migrate all the OpenShift to Kubernetes, and also maybe in the future, we're going to have automated migrations from OpenShift to Kubernetes. So there will be scripts that you can tell it a project name, and Lagoon will automatically migrate that from OpenShift to Kubernetes clusters, fully automated for you. The only thing you need to do is maybe change the DNS or the CDN configuration, but that's it. And we're also going to have Kubernetes to Kubernetes migrations. Let's say if you have a cluster in a new location and you want to migrate everything over there, Lagoon will have automated scripts that help you doing all of this. And we really think this will make it even easier in the future to have the management of Kubernetes cluster in different regions with different providers, multi-cloud environments. This will make it much, much easier and to manage. So this is basically what we're going to bring in Lagoon 2.0. Are there any questions so far, Philip?
Yes, something just popped up. As a developer, how much knowledge of Kubernetes do I need to have, if any?
That's a really good question. We really want to make sure that you need no Kubernetes knowledge at all. So if you want to use Lagoon to deploy your application, all you need to do is you need to add a couple of files to your Git repository that teach Lagoon what type of application it is, what services do you need, which tasks you need to run. These are all based around YAML, and we have example files for them for the most common applications out there. So a lot of them, you just copy paste them in there, maybe modify them a little bit, and that's all you need to do. Lagoon will do everything for you. It will talk to Kubernetes, it will check that the correct permissions are there, and it will set up everything inside the Kubernetes cluster. But the really cool thing also is Lagoon also shows you what it actually does. So with Lagoon, you can then check, for example, what actually has Lagoon done in the Kubernetes cluster. So you can also learn from it. You can learn what are the best practices to deploy against Kubernetes. And if you know more about it, you can also change slight behaviors in Lagoon even more. So it's a perfect tool to learn how to use Kubernetes to deploy your application and learn it and do more and more. But if you want to start with it, there is zero knowledge needed about Kubernetes.
Okay, that is currently everything we have as far as the questions are concerned. If anything comes up, I will move it into the next sectional Q&A. I think we can just move on.
Cool. All right, it's demo time. All right, so let's do a live demo, shall we? The first thing we want to do is we're going to deploy the Drupal example project on GitHub. I'm going to shortly show it to you. And so you can access it, you can see it as well. And we're going to deploy today. We chose an AWS deployment. So let's go and look at that. So over here, the first thing I want to show you is the Kubernetes cluster. So we used an AWS EKS. So this is the Kubernetes environment created inside an AWS account. It's super easy. You basically just go here and create a cluster. It will set you up with a cluster. It will configure it for you, and you have access to all of it. And so that's where, or that's what we're using in this demo. The same would also work against Azure. It will also work against Google Cloud or any other Kubernetes cluster, even bare metal. It's going to be exactly the same, but in this case, we're going to show you the AWS deployment. On the Lagoon, on the code side, as I mentioned, we have a Kubernetes Drupal example, which is what we're going to use today. It's open source, you can access it. And if we look inside that Git repository, so for everybody that has ever deployed with Lagoon, it looks exactly the same as you would deploy with Lagoon version 1. So we have a lagoon.yaml that has a couple of post rollout tasks in here to install a Drupal, config import, things like that, and Docker Compose that we use for local development and also teach Lagoon which services you need. For example, here we tell it we need an Nginx server. This is the Lagoon type. We have a PHP container. There's a Lagoon type as well here. So this is exactly the same. The same repository that I have here, I could use against Lagoon 2 or Lagoon version 1. It's exactly the same. For local development, also nothing changes. So all I do is I run Docker Compose up -d. which will start all the containers. In my case, they're already running. I can then exec into the CLI container. So now I'm here, I have Drush available, I have Composer available. Again, this is exactly the same like with Lagoon with Lagoon version 1. I can now run Drush ULI. This will give me a link to docker.amazee.io. This points to my local environment. So if I open this, I can see loaded Drupal in this example, which has the site name right now. It says Drupal, welcome to Drupal on Kubernetes. So what I want to do now, I want to change this. I go into the site settings and let's change it to that. So I just change the site name, do something super easy. And I go back to the start page. We can see Kubernetes with Lagoon 2.0. Nothing fancy here so far, no surprise. I can now, because this is Drupal and this is Drupal 8, I can config export this. Guess I want to save this. And if I hit diff here, we can see that this is the change that I just did. Before I'm going to commit and add that, I'm going to create a new branch. So I create my branch demo. Oh, or let's call it, let's actually delete that branch real fast. And let's create it again. Perfect. I'm going to git add that. I'm going to commit that. Call it Lagoon 2.0. And I push this. Now, before I actually push, what is going to happen now is like with any OpenShift on any other OpenShift environment, GitHub will tell Lagoon that a new push has happened in this Git environment. And then Lagoon will check which cluster this is set up. It will realize that the cluster is a Kubernetes cluster and not an OpenShift cluster, and it will change its behavior to actually deploy against Kubernetes. You might know that OpenShift and Kubernetes is actually very similar in terms of API, but there are slight changes. So Lagoon has the capability to deploy against both, and it will automatically see that it can push against another one. So I will push that here. This goes to GitHub, and GitHub will now inform Lagoon. I will go to my Lagoon UI, and this looks exactly the same. It's exactly the same system that you already know from OpenShift, just that it's now in the background, and we can see there's a demo. Another really cool thing that we can see now is because we are using Kubernetes, Kubernetes has a lot of additional capabilities for visualization. One of the tools we're using here is WeaveScope. WeaveScope is a visualization tool for Kubernetes. Now, we couldn't use this in OpenShift, but it's possible in Kubernetes. This is a tool right now that is only available for cluster admins. So if you would run a dedicated cluster, you could have access to that in the cloud. This is only for Amazee.io, but we can see how this visualization is really cool. So there was a Lagoon build container that now started to do building, and we saw now new pods popping up with an Nginx persistent storage and the Redis and the Varnish. And so this is something that has never been possible before because not all these tools support this. We can also, for example, look at the build logs in real time, something that wasn't really possible before. And so we can see Drupal is currently installing. So if we give it a couple more seconds, we can see in real time how how the installation is done. And that's really the other reason as well that we want to use the Kubernetes. There's so many tools out there that could be used, and right now we can't. So with going to Kubernetes, we're gonna open ourselves up in a much bigger environment or a much bigger ecosystem that we can use. We can see Drupal is installed, and there's now a couple of other post rollout tasks that they're gonna run, and the cache rebuild has been completed. And if we go back, we can see the Lagoon build has 0 containers, so it's basically done. And we can see how the other containers are starting to talk to each other. And if we go back to the Lagoon UI, and I go into that demo branch that we saw before, I can see if I go to deployment, the deployment has been completed. It took 2 minutes. It's actually faster than what we see in OpenShift. And if we go to the overview, we can see there, like in OpenShift, it created automatically routes for us Lagoon automatically creates routes for each of the servers that supports an HTTP. So in this case, we have Nginx and Varnish. And if I go to the Nginx or the Varnish, looks like that something didn't work, but let me just try that. Demos, of course, they always want to fail. Yes, looks like we have a certification issue. Well, doesn't matter. But basically, if we check, let me shortly check without HTTPS. Nope, doesn't work. Oh well, demos are meant to fail. But basically, we can see that it automatically deployed the site and to the cluster, and it would do the same for PRs, pull requests, all the same functionality that you know is all exactly there. So we can see here there is an actually master site that we have deployed. And this one is the master that we didn't merge into yet from Lagoon 2.0 change. So this is why here we don't have that change. But if I would now merge the develop into master, it would automatically deploy that. So this is how the deployment system works. And we can see there's really no change. If you are used to Lagoon 1.0, it's gonna be the exact same environment, or how you deploy, how the Lagoon UI works, and all that stuff is exactly gonna be the same. Okay, do we have more questions, Philip?
Yes, there is two already waiting for you. The first one comes from Alessio asking, are you using an on-premise Kubernetes cluster? What is the approach that you use to fully manage services like EKS on AWS?
Yes, so Lagoon has really no requirements where the cluster or where Kubernetes is running. So it could be on premises, just bare metal. It can be a managed Kubernetes at AWS or anywhere else. We ourselves, to manage the Kubernetes clusters, we use Terraform. So we use Terraform to set up Kubernetes clusters in, let's say, AWS and Azure. And we're using Rancher to manage all these clusters, or to access all these clusters. But that's really something that we internally at Amazee.io use. This can be done by any other thing. At the end, what Lagoon requires is just a Kubernetes API endpoint that it can talk to, because Lagoon just talks Kubernetes API to the cluster. So it can really be running anywhere or wherever cluster that you might have. Your preferred way, there is probably hundreds different ways how to start Kubernetes clusters. You don't need to use Terraform or Rancher. That's just what we are currently using at Amazee.io.
Okay, then thank you so much for that. The second question is, we're already using Kubernetes cluster on AWS. Is there a possibility to link Amazee.io Lagoon to the existing Kubernetes cluster and use Lagoon as a service?
Yes, Lagoon as a service is something we are not offering right now, but we're really, really thinking about it. So the idea will basically be what was just described. Usually, if you come to Amazee.io, we manage the Kubernetes cluster also for you, and you can use Lagoon. But we're thinking about how could we use this to already deploy into existing Kubernetes clusters that are not managed by Amazee.io, hence the name Lagoon as a service. If you're interested in that, please send us an email at hello@amazee.io, because we really want to talk to you. We want to figure out how exactly could that work. We really believe that this could be something for the future where we could really work together with existing teams that manage already Kubernetes. It is, though, a slightly bit more complex than if we manage everything, because, for example, we have some dependencies on the cluster. We need some things running inside the cluster. So there's some things we need to figure out. But I really think that we can make it work, and it's something that we really want to do. So please reach out to us, and we're happy to talk to you and figure out how we can do this.
Okay, yeah, there is more questions coming in. The next one would be, can I install Lagoon using Helm?
Yes and no. We are working on full Helm support to install Lagoon in a cluster. How it works right now is that we have Helm support to install just the parts that are needed to run Kubernetes, to have Lagoon deploy against any Kubernetes. So all the small dependencies we have inside any Kubernetes cluster, what we call Lagoon remote, this is currently deployed via Helm, but this is much smaller. Lagoon itself, which consists around right now around 20 different services, this is actually deployed via Lagoon itself. So you basically use Lagoon, an existing Lagoon, to deploy another Lagoon somewhere else. It's like a virus that multiplies itself. So we use that idea. There is definitely the idea to also use Helm from the very beginning. On the other side, I have to say, we see more and more operators coming up. So there's also the idea of using a Lagoon operator, maybe to deploy a Lagoon. So there is some more happening there, but we definitely want to use the most modern tools like Helm, operators, stuff like that.
All right. There is another one. Will there be any differences regarding logs, or will they still be available in Kibana no matter what the cluster is?
Correct. This will still work exactly the same. We are using the same log collectors that we use in OpenShift. We're also using in Kubernetes, and we ship them to the same Kibana UI. So you have, like in OpenShift, you have access to Kibana, you log in with your Lagoon account, and you will see all the different logs in there. There will maybe be some additional logs that we currently don't have in OpenShift that we want to show in Kibana with Kubernetes. Also, some better filtering capabilities and things like that, but it will be, the default will be exactly the same.
Okay, thank you very much. The last one for now, it seems, is there any limitation with decoupled architectures like Gatsby status content generator?
No. In the end, Lagoon really runs containers for you with applications inside of them. And whatever the application really needs, Lagoon doesn't really bother. So as long as you can run whatever you want to do with decoupled architectures, things like that, as long as they can be pulled into containers, and especially modern web frameworks like Gatsby, they are fully built from the beginning to be used in containers. You can deploy them with Lagoon, and you can do that. We have built quite complex infrastructures where we have, for example, multiple front ends that all talk to one content repository. It's really, the possibilities are endless there. And if it's a bit different than like standard things where you just have like one front end container and then maybe a backend, there might be some changes that we need to do, but this is also where we help from an Amazee.io side, where we really help you to set up clusters, set up your application, our very best way in terms of performance, cost usage, stuff like that. All right, let's continue. There's one more slide that we really want to show you, and then I think we can do more QA at the very end.
Okay, I'm moving those open questions, just so everyone in the audience is aware of that. I'm moving your open questions to the final Q&A. You're not forgotten, we will address them.
Perfect, thank you. All right, yes, and there is even more. So everything you see right now is what is going to happen in Lagoon 2.0, but there is much, much more. And there's actually many things that we cannot cover all of them, but here's just a bit an overview of what is going to happen. One of the things that we're working on is the security dashboard. I mentioned before, we're having a Harbor integration now, but it's not shown in the Lagoon UI. So what we want to do is we want to show if Harbor finds any security issues, we want to show them in the Lagoon UI for you, that you can see what is happening. This is a huge topic, especially in enterprise environments where we need to show what is happening in these containers. So the idea is you will go to the Lagoon UI and you see all different security issues found by Harbor. But not only that, we also want to do a Drutiny integration. So let's say you have Drutiny running in your Drupal environment and Drutiny finds a problem. Drutiny will show them in the Lagoon UI as well. So you can see, let's say, if you define the user one is not allowed in to be enabled, Drutiny will show it to you. This then goes to security notifications. So if Drutiny finds something, this will send automatically notifications out. Another highly requested feature is alerting from logs. we really want to provide our customers the possibility to say, if there's a specific log entry happening, send me an email or alert me in some other way via Slack or so. This is not easy, but we really want to implement this, because we see there are many big sites now hosted with Lagoon that need this capability. The other thing, of course, is real-time build logs. Right now, you can only see the logs after the build has completely been finished. We're working hard on figuring out a way, how can we show it to you in real time? You saw it before in vScope that how this is possible in a UI to show it, and we also want to bring this to the Lagoon UI. You probably have heard our announcement that we are improving the local development experience as well. We are working on a Lando integration. So this means you can use Lando with Lagoon images directly, and you don't have to install any other tool or anything else. If you have Lando already, you're ready to go and you can use it. So you see, there is many more things that are coming. We're working really hard on getting them. If you're interested to see the process and all of them, the status of them, go to our GitHub, amazio/Lagoon. You will see the issues there. There's also a project Kanban board where you can see the roadmap. It's not super up to date right now. This is going to happen over the next couple of days, but we are really working on adding a lot of cool new features to Lagoon and want to release them as fast as possible to all of you so you can use them and build better applications. Okay, this is it. I see we have more questions. Philip.
Yes, indeed. I moved two of them from the sectional Q&A. The first one comes from Eric. He's asking, how does autoscaling on Kubernetes worker nodes work besides on pod level, for example, HPA?
Yes, so cluster autoscaling on Kubernetes compute node level works basically with a combination of the cluster itself and the infrastructure provider. So for example, in AWS, you create an autoscaling group where you tell AWS that it can automatically scale the cluster from 3 compute nodes up to, let's say, 20 or 30 compute nodes. But it's actually not AWS that does the scaling, but instead what you do, there's an open source tool called Cluster Autoscaler. This is an operator, so it's a pod that is running inside the cluster itself. And this pod constantly monitors how many compute nodes are there and how many pods are actually on the cluster. And if this operator sees that there's a new pod started, that for example, it wouldn't have enough space inside the cluster, it will automatically talk via the APIs of the infrastructure provider, in this case AWS, but it has support also for Azure, Google Cloud, and others. And it will automatically tell AWS to scale the auto-scaling group up by 1 node. And then AWS starts a new compute node. This node will automatically be registered inside the cluster. That happens fully automatically. And then you have more space and that pod can automatically run. So this is done with a pod inside the cluster that talks with the APIs of the infrastructure. The really cool thing is it also works the other way around. So let's say you scale up and you have 10 nodes, but each of these nodes only have a couple of pods running. The cluster autoscaler also goes there and sees that if it would shuffle around the pods a bit, it could actually remove some nodes. And this is what it's going to do. So it will automatically move pods from one compute node to another one, so that the compute node itself is empty, and then it will tell the autoscaler to remove that specific node. So it not only goes up, but it also goes down. And we're using this now with the first couple of clusters that we're using with Kubernetes, and it works really, really well. So you can imagine with all of the COVID-19 stuff that is happening right now, we have sites that experience 100 times more traffic than usual. And such cluster autoscalers are vital for these things. So we see environments where like over the night, maybe the cluster is only 2-3 nodes, but then during the day where there's a lot of traffic, the cluster scales automatically up to 5 to 6 nodes. But again, we're using all open source tools for that. It's Cluster Autoscaler. If you search for that on GitHub, and it's really, really nice to work with it. Philip.
Okay, wonderful. Next question comes from Rodrigo. He would like to know, can I deploy full services ready to use on Lagoon like a GitLab instance?
Yes and no. This goes back to that. So one of the ideas we're having, and I have to say this is very, very preliminary. So internally, Lagoon uses now Helm to deploy your application. So the idea, of course, that jumps into that is, could we use any Helm charts to deploy with Lagoon? This is not possible right now, but it should be possible. So GitLab, for example, has a Helm chart. So it would be really, really nice that you tell Lagoon, hey, deploy that Helm chart beside these other maybe containers. This is not going to be super easy because Helm has a bit of understanding how things should work. Lagoon has a bit slightly different understandings how this should work. But we are actually, we know, or we have a contact to the Helm maintainers. So that would, of course, be really, really nice to combine this somehow. If you're interested to try this out, to play, to architect, I would be super interested to talk. So either reach out to me or create an issue on GitHub, because I think that would be really cool to deploy things like you mentioned GitLab or other things that already have Helm chart support via Lagoon. So, but what is definitely possible is if we have a Kubernetes cluster, especially a dedicated one, you can deploy any other things into that cluster. Not everything needs to be deployed via Lagoon. So we have, for example, clusters where we run GitLab and we just use the Helm charts to deploy a GitLab, and then all the Drupal sites are deployed by Lagoon. It's not the very best system, of course, but it is a possible workaround until Lagoon has full support for the Helm charts.
Okay, wonderful. Thank you. We have another one from Alessio. Regarding monitoring of your cluster, do you use open source solutions like Prometheus? And what kind of tools do you use for alerting and notifications in if something went wrong? Grafana.
Yes, all of them. Yes, we totally use, so our monitoring stack consists of Prometheus, Grafana, and Alert Manager, the super standards that you will see every other person using in Kubernetes, especially on an open source level. Today, all of these tools, so for example, Grafana Access is only for the cluster admins. So in our cloud, where we run the cluster and our customers just deploy some projects in there, and there is no access for Grafana for our customers. If you have a dedicated cluster where only we deploy only your projects into a dedicated Kubernetes cluster, you as our customer have access to Prometheus, Grafana, Alert Manager, you can have all of that. But we're also working on figuring out how could we give all customers access to Grafana, for example, and then you can do alerting from there. This means we need to teach Grafana about multi-tenancy. There is some stuff already there that we can touch into and use. It's a bit more complex, unfortunately, though, but this is definitely the end goal, that all our customers can see Grafana dashboards of their pods, their usage of resources. They can see when did they scale up, when did it scale down, all the different things we definitely want to do. But internally at Amazy, yes, we're using Prometheus, Grafana, and Alert Manager, and to monitor the cluster.
Okay, that's currently everything in the question pipeline. Maybe we're going to give the audience another 30 seconds if there's anything open. I have also just posted the email address for all webinar-related questions into the chat, which is webinars@amazy.com. Should anything after this presentation come up that you'd like to find out, you can send us an email and we'll get back to you on that one. But for now, it looks like we may have concluded this Q&A session.
Cool. All right. I think with that, thanks a lot. We will send out the recording of this. We will send out to everybody, and we'll also want to make it available on our blogs on the Amazy website, so you can look at it again. You can send it around. But yeah, thanks everybody for joining.
Yes, and also obviously thank you for presenting. And as Michael already said, we will shortly follow up with all of the recordings and a recap blog of this very presentation. Thank you everyone for joining, and we shall see you for the next one. Bye-bye.
Bye-bye. Thank you.